So we're almost done with our coverage of the ImageStreamGang case study. What's left is to talk about arbitrary-arity methods, what they are, what their purpose is in this context, and then we'll walk through the encapsulation of said arbitrary-arity method, allOf, in the context of the case study. So let's first talk about how we need to use them in this context. So if you recall, the flat map operation output a stream of completable futures to tasks that are running asynchronously in the common fork join pool that are doing downloading, transforming, and storing of images that are not cached. So that's what flat map is doing. And because we're using completable futures, what we want to be able to do is coalesce or collect all those things into a single completable future. And that will allow us to be able to wait in one place for all that asynchronous computation to finish. So collect returns a completable future to something that will do that. The other thing, of course, collect does is it triggers all the intermediate operations. So always remember that with streams, nothing starts to do anything useful until collect is hit. That's starts all the wheels in motion, as it were. And so it will return one completable future, and all this stuff will start up and do all the asynchronous programming we've talked about in the previous lessons. The toFuture factor method, which we're going to look at in more detail, returns that completable future that completes when all the completable futures in the stream complete. So hopefully that is becoming clear by now. Now what happens at this point is we then use the thenApply completion stage method to run an action, to register and then ultimately run an action that will log the results of all the computations after that final completable future finishes, indicating everything else is done. And this is kind of an interesting example. If you look here, you can see that we're going to use the flat map method on stream to get rid of all the empty optionals. If you recall, we could have empty optionals here if there were cached images, and this will remove all the empty optionals in the stream. That feature came in Java 9. We'll talk a bit more about this later, but that was something that was added to Java 9 to do that. In Java 8, if you were stuck with the Java 8 implementation, which we were for a while with Android, what you'd have to do was filter out things that were not present. So we'd only allow stuff that was present, and then use this somewhat more verbose and long-winded way of doing what's done nice and concisely here. So in essence, Java 8 is just more verbose. And you can learn more about Java 9's optional support here. It's a pretty minor tweak, but it did clean up code like this. Now, what we're going to do here is, as you'll see, the StreamOfFuturesCollector is the thing that's encapsulating all this stuff. So that's what it's doing. And we're going to then finally use the join operation, which will wait until all the asynchronous processing is complete. So the key thing to note that this is the one and only place that we use join in the entire program. And there's really sort of no easy way around that, given the way we've designed this particular framework. If we designed the framework slightly differently, we could have made it to be even more asynchronous. And I'll talk about ways of doing that when we get to the next lesson series, the next section on reactive programming. We'll come up with a cool way to handle that. But for now, we need this one and only join. So it's not a bad thing, but we only have to do it in one place. And of course, when all is said and done, the images will be displayed after the asynchronous processing completes. So all this stuff runs in the background, and then finally, after everything's done, we will return from this call, and then all the images will be left lying around in some kind of folder. And there's another part of the program which can go ahead and display those images. For the Android version of this ImageStreamGang app, the case study, we actually have a cool little gallery-like service that runs to display the images. There's also a command line version where you'd have to go and run some kind of image viewer, like the kind of thing you would get by using the File Explorer on Windows or the Finder on Mac, which will go ahead and display the results. So it kind of depends on what platform you're on as to how these different things work. So that's the end of the overview of applying arbitrary-arity methods.